Well, welcome back, everyone. If you remember, we're talking about screening. The goal of screening is to detect a disease that has serious consequences, a disease that has a treatment, if given earlier, leads to better outcome, and a disease that has a high prevalence in what we call the detectable preclinical phase to justify expending the resources to do a screening in a population. We want to have enough cases of disease to detect. So remember this, the detectable preclinical phase was that period of time between when the screening test could detect the existence of disease up until the point in time when the disease would normally be detected by symptoms. That's when we're doing the screening program. And the idea, again, is to apply a test during that detectable preclinical phase to detect those people who are likely to have disease, to give them a treatment, hopefully if given earlier leads to better outcomes. So let's talk a minute about what makes up a good screening test, a test to use as the basis of a screening program. And Marcello's already talked about screening tests before. We want a test that has high accuracy, meaning, remember, we're going to classify people according to the test as being either likely or unlikely to having a disease. So we want the test to have a property that anybody who tests positive is very likely to have the disease, and everybody who tests negative is very unlikely to have the disease. That's the way we classify people. So how do we measure the ability of the test to classify people correctly? As Marcello has described in his earlier lectures, we can calculate what is known as the sensitivity and the specificity of a test. The sensitivity of a test is among people who really have the disease, what proportion are correctly classified by the test as being likely to have the disease, are classified as positive by the test. So it's the probability of the test being positive among the people who really have the disease. Among people who have the disease in the detectable preclinical phase, the sensitivity is the proportion of those people whose tests are called positive. And we want that sensitivity to be high. We want to be able to detect all these people who have disease unknown to them in this preclinical phase by giving them a screening test. And anyone who's tested positive, we want to be able to say that that positive test is capturing most of the people who actually have the disease. That's what high sensitivity means. On the other hand, we want the test also to be correct when it says you're unlikely to have the disease, meaning among people who really don't have the disease, say women who don't have breast cancer, preclinical breast cancer, specificity means the proportion who are correctly classified as negative by the test, unlikely to have disease, and we want that test also to have high specificity. That's what I mean by a very accurate test, high sensitivity and high specificity. Now, those are important features of a test. Now, there are other important features we also want to take into account. We'd like to give a test that's low in cost. We'd like to have a screening program that we can afford to give to everybody in our population. So if a screening test is very expensive to give, it might break our budget and make it infeasible to use in a screening program. We'd like to have a test that's painless, that people are going to be agreeing to undergo this test because there's less pain, less discomfort involved in it. We don't want a test that causes morbidity. For example, if we are radiating people with mammograms, realize we are exposing women to radiation therapy. Hopefully not much in a mammogram, but nevertheless, that radiation could prove to be harmful, so we also want a screening test that doesn't have any harmful side effects, any morbidity associated with it. So those are the characteristics we have in mind when we think about the properties of a good screening test as part of our screening program. Well, here's the formulas that Marcello gave you before, just to make sure we're all on the same page. What does sensitivity and specificity refer to in this detectable preclinical phase? Well, people either have the disease or don't have the disease in the detectable preclinical phase. What our test is going to do is going to label people either being positive, test is positive, or being negative. What does specificity refer to and what does sensitivity refer to? Well, in terms of sensitivity, we look among people who really have the disease. They're A plus C individuals. A of them are correctly being classified as by having likely to have the disease by the test. So the sensitivity is A divided by A plus C. On the other hand, specificity refers to people who really don't have the disease. we have B plus D individuals, and D of them are correctly classified as negative by a good screening test. So the specificity is nothing more than D over B plus D. And we would like to have a screening test that is both high in sensitivity and high in specificity, to label people likely to have disease, unlikely to have disease in the right way, by having both of these proportions being high. So here's an example of a screening test looking for the screening for breast cancer from what was known as the HIP program. They ended up screening women. There were 177 women who actually had the disease during the detectable preclinical phase. Well, how can you know a woman really has disease in a preclinical phase? Well, what they did is they followed up women over time and see what happened to people in terms of gold standard diagnoses. And they were able to estimate that when this screening program was given, 177 women actually had breast cancer that should have been detected by the mammograms, by the test that was given. Well, what did the mammogram show? The mammogram showed positive results for 132 of those women. So the sensitivity of the mammogram among those 177 people who, after the fact, were expected to have disease at the time the screening test was given, the sensitivity would be 132 over 177, or 75%. What's the specificity? There are a much larger number of people. There are 664,633 women who, as far as the investigators could say after they followed them up, did not have disease, did not have breast cancer in the detectable preclinical phase when the screening test was given. 63,650 of them were labeled correctly as having a negative test, as being unlikely to have breast cancer. So what's the specificity? 63,650 divided by 64,633, or 98%. So the sensitivity, the specificity of the screening test, the mammogram, among these 64,810 individuals was a sensitivity of 75%, a specificity of 98%. That's describing the accuracy of the screening test in this particular population. Next time, when we come back, I want to go a step further. Now let's talk not just about the screening test, but about the screening program, which involves giving this test to a specific set of people at a specific schedule, and to try to use that as a metric to see how well this screening is useful in that population. So that's what we'll talk about next time. See you then.